In engineering mechanics, all physical quantities can be described, can be completely specified either by its magnitude or by a combination of magnitude and direction. So you will need either magnitude or a combination of magnitude and direction for describing all physical quantities in engineering mechanics. Those physical quantities that are completely specified by magnitude only are called scalars. And those that are completely specified by magnitude and direction are called vectors. So, scalars and vectors. It's a bit difficult to always distinguish between scalar and vector. I'll give you a simple technique so that you can remember which is scalar and which is vector, or that will help you distinguish between these two. Scalar starts with S, vector starts with V. So S for scalar, V for vector. And if you consider the English alphabet, S, T, U, V, and considering scalar and vector, S comes first ahead of V, which is coming second if you consider S and V. So in the English alphabet, S for scalar comes at number 1 and V for vector comes at number 2 if you consider scalar and vector only. So scalar can be described by a single parameter, that is magnitude, and vector can be completely specified by two parameters, that is magnitude and direction. I hope this helps. S for scalar, V for vector. In the alphabetic order, S comes first and V comes second. So S uses one parameter, that is magnitude, for a complete description, whereas V for vector uses two parameters for a complete description, that is magnitude and direction. So if you understand this, you will never forget, or you can anytime you can remember which is scalar and which is vector. So what are the examples for scalar and vector? You draw a line say you draw a line and call it length, having a length of maybe say 40. Now that is a scalar quantity. because it's only a length. If you measure from here to here, say A to B, if you measure A to B or B to A, it's the same. But the same length, or a similar length, that is again shown as a length, but here you say this is a force acting on a body in this direction. So it's a body of mass m, and there is a force F acting on that body, which has got a magnitude of 110 Newton and a direction or a sense in this way. So now that you have a magnitude and a direction, you have a magnitude of 110 Newton and a direction or sense. So the angle that the vector makes with the reference axis is its direction. Say theta. You can also specify the angle here. That depends on where your reference axis is. So if you are taking the reference axis from here, you can also specify the angle here as well. That depends where you specify, actually, where your reference angle is. In this case, both thetas are same, but there can be differences. So to simplify, if you draw a line showing a force, and suppose your reference line is here, then the angle, you have got a force in this direction, say F equal to 100 Newton, and that is your angle. That depends which is your reference angle. So this is a vector because it has got a magnitude and a direction. This is its direction or line of action for in terms of forces. So scalars and vectors. S for scalar, V for vector. Scalar needs one quantity, that is magnitude, for a complete description, whereas vector needs two quantities, that is magnitude and direction, for a complete description. Length is an example of scalar. Mass is an example of scalar. Time is an example of scalar. And force is an example of vector. It have to have a magnitude and a direction or line of action. The axis system. A thorough understanding of the axis system will simplify your force analysis and force vector analysis. So how we can define an axis system? Suppose you're going to write down from 0 to plus infinity and from 0 to minus infinity, and then connect all those numbers with a straight line. You will get a line like this, which has an origin at 0 here and two ends which are leading to infinity. This is called a number line. And otherwise, a one-dimensional axis, you have only one dimension here. Any point on this line you can define by a single number. If you say 10, you have a point 10 here, somewhere here. Say 1000, you have a point 1000 somewhere here. You say minus 23, you have it somewhere here. Any point on this line you can define with a number. The important thing to note in a number line is on either side of 0, that is extending to infinity, from 0 to positive infinity and from 0 to negative infinity. So that is a number line, and that is a fundamental line of an axis system. It enables you to define a point anywhere in the line with a single value. Now, if you have two number lines running perpendicular to each other, then that makes a two-dimensional axis. For convenience, let's call it x-axis and let's call it y-axis. Again, as in the previous slide, it originates from 0, extends to positive infinity and negative infinity and positive infinity and negative infinity. So you have positive values here, negative values here, positive here and negative here. And that requires you to have two values, that is the x value and the y value, to define a point in the axis system. Say minus 2, 10, which is x and y. So minus 2 here and 10 here. So you define the point here. Similarly, you can define any point in the space with two numbers. Remember, these lines extends to infinity. So you don't have limits. You can move anywhere in this line. Similarly, if you have three axes or three number lines which are perpendicular to each other, then that creates a three-dimensional axis system where you need x, y and z coordinates to define a point. So this is your x-axis, y-axis, and your z-axis. So again, from origin, these axis extends to infinity. So you can literally define any point if you have the 3 coordinates. So this will enable you to define a point in the space. And because these axes are extending to infinity, you can define a point anywhere in the space. So if you have a cube like this with x, y, and z axis, you can define any point in the cube with these 3 coordinate values, and you can move this plane to infinity. You can also move this plane to infinity. Remember, this line extends to infinity, and that is a case with all the 6 sides of this cube. You can move these planes to infinity. That will give you the freedom to define any point in the space with an infinite number of choices. So that defines an axis system, and how we are going to use the axis system in engineering mechanics. Suppose you have a force vector. Suppose you have a force vector here which has got a magnitude of, say, 70 kilonewton and a direction of theta here. So how we are going to use the axis system for the analysis of this force? As I said before, you have infinite choice of axis. So if you draw a complete axis here to join your force, and you draw your next axis to complete the force, complete the axis, that gives you the freedom to analyze the force. So your force is creating an angle theta with the x-axis, or 90 minus theta with the y-axis. So now you can analyze your force, which we will study in the next module. As I said before, because you have the freedom to move anywhere in the space, you don't have to worry about any force at all. If your force is at a different angle, say like this, which has got a direction in this way, and say it's 80 kilonewton, you don't have to worry at all because you have the freedom to move your axis anywhere. Now you have the choice of selecting your axis system like this, and your origin here. Now you have your x-axis here and y here, you have a theta with the x-axis, and again 90 minus theta with the y-axis. So the analysis of forces, which we will study in the next module, but this is how we are using the axis system in engineering mechanics, or this is a primary use of an axis system. So you need to understand a couple of things in the axis system. Primarily, an axis system comprises of number lines which has got an origin and extends to positive infinity and negative infinity. In a two-dimensional axis system, you need x and y parameters or x and y coordinates to define any point in the axis system. Similarly, in a three-dimensional axis system, you need x, y, and z coordinates to define a point. And this is how we are going to use an axis system in the analysis of forces and force vectors. We will study that in the upcoming videos.